Yeah, thanks, Margaret. I'm Coleman, Director of Product Management here at IonQ, and like Margaret mentioned, one of the ways to think about this enterprise grade pillar is as a pillar that's all about taking our high performance, highly scalable systems and helping them become useful commercial objects as well as scientifically and technically interesting devices. And the way we do that is by starting with the best qubit technology, building it into the best hardware, and then building or integrating all of the other pieces up the full quantum stack to enable everything else we need to drive meaningful commercial value at production scale. Reliability, resilience, usability, and application-oriented performance. So to walk you through this picture on screen briefly, the hardware is still at the core. It's still the most significant bit for IonQ's continued customer success and commercial success. But then on top of that, you need a robust software suite and access platform. This runs on the computer as well as around the computer. And we build a lot of this software in-house, but we also believe in and support a broad quantum ecosystem of open source and third-party access platforms and software packages, including all of the major cloud providers and what they have to offer. And all of that software is there to enable this top layer, meaningful commercial application development and deployment, which again happens in-house via IonQ's stellar application development team, and often also with amazing partners like the ones listed here, and sometimes even through people outside of the building. We regularly see application breakthroughs coming from places we didn't expect because we have this robust access platform. And so for the rest of the session, my colleagues and I are going to walk through some of our latest updates in each of these three layers, starting with the middle because it's, like Margaret mentioned, this word interoperability. It's really the place where we are able to bring these two sides, these other two layers of the stack together to create useful applications and meaningful progress. So if we'll jump to the next slide, this hybrid story is really all about tying these two pieces together, right? I think a lot of the ecosystem and messaging around quantum is still treating quantum processors as these sort of standalone devices, off in a special corner to kind of tinker or play with or learn about. But the long-term vision here is commercial advantage. And if we make the bar for taking advantage of a quantum computer, totally reinventing your existing classical infrastructure, the way you solve problems in the world today with computers, the places where quantum computers are likely to provide advantage and the people it'll be able to help are going to shrink dramatically. And this is really what we mean when we say hybrid. It's more of a roadmap theme, a collection of capabilities than any one individual feature or option that we provide. And they're all about bringing quantum computing into the existing production classical computing environment as a useful tool, which primarily means integration and operability with classical computing. So we're going to start with this new cluster of capabilities that we're launching under the banner of IonQ Hybrid Services. These are a collection of capabilities that span all the way from the cloud, all the way down to the hardware to help enable the kinds of quantum classical integration that we believe are going to be key to unlocking commercial value at scale by allowing us to effectively take advantage of the things that aren't the quantum computer to provide real value. And if you'll go to the next slide, to put all of that a bit more simply, this is what we're trying to do in the long term. Quantum should just be part of the production value stack. Another way of potentially many to get the best results, simple as. We want the capabilities of quantum computing, the value it unlocks, the new things it'll let people do to be incredibly exciting, world-changing, right? But we want the act of actually using a quantum computer to be effectively boring. As simple as it is to take advantage of a GPU to accelerate parts of a workload today. And this is starting to be a story that's more prevalent, I think, in the industry. But a lot of folks, including some hardware vendors, don't really have a sense of what it means to actually do that, the full path to getting there, to get all the way to production sorry, this is a bit of a mouthful, a production quantum accelerated application. There we go. And so I'd like to talk about how IonQ thinks about that on the next slide. How do we do that in detail? We like to think of it here at IonQ as a virtuous cycle of how quantum computers can accelerate classical workloads and workflows, sort of on this top half. And on the other side, how classical can actually enhance the quantum computers themselves through all sorts of techniques that enhance performance, speed, reliability, and usability through software alone without any change to the physics, the optomechanics, any of these things. And for now, for us, this exists mostly as two different roadmap thrusts. Here at the top, we're driving towards improving the end user programming model and accelerating at the application layer. Whereas at the bottom here, we're driving towards improving and ultimately virtualizing the qubits and the QPUs via photonic interconnects, advanced error mitigation, and error correction, all of which require the ability to inject classical logic into a given quantum program at certain points. So to actually do a quantum error correction routine, you need to detect the errors, which is a thing that requires a little bit of classical computation. Then you need to be able to take different branches on your quantum gates to then actually correct for those errors, all while the computation is still running, while your quantum information is still coherent. And that requires new capabilities, sort of classical enhancing quantum. And for this third piece, we do all of this in what we call an application-driven way. We believe it's necessary to start with the end in mind and enable the researchers of today to help us understand what we need for the production applications of tomorrow. But to be clear, we're already starting to see the lines blur between these two sides, between kind of the quantum accelerates classical and the classical enhances quantum. And we think in the long run, these two will get slowly more and more like one thing as these systems become more tightly integrated. And so that's sort of how we think about it, but how do we measure ourselves? What's the scorecard here? So if we go to the next slide, if we've done our job right, the benefits you'll see as an application researcher or an end user, or even just someone who's kind of further downstream of a quantum advantage application, say you're a chemist or a material scientist, and you're just using this thing and you're not actually writing the circuits yourselves, they can be described in kind of three big buckets. And if you look at these buckets, they're very similar to the buckets you'd see when describing kind of any high-performance computing platform, and that's the point. That's the application and value-driven focus we want to bring to the table here. So to give you an example, individual gate speed is important, and it's a key factor in overall algorithmic time to solution, but that overall algorithmic time to solution is the thing we actually care about. That's the thing that creates real commercial value. Similarly, qubit performance is incredibly important and a key driver of algorithmic performance, but there are a lot of other things we can do to enhance algorithmic performance, and we want to be pushing forward on those just as well, just while we are also pushing forward on qubit performance. And of course, usability is also critical. It's like in the other two cases, we want to move away from raw qubits and circuits and towards value. And the way we do that is by making all of the stuff around running a circuit as efficient and simple as possible. We want our applications researchers and other applications researchers to be doing their best work on IonQ systems, not fighting with the infrastructure, fighting with native gate mapping, or anything like that, unless, of course, that's where your research is. We're not removing low-level access. To be clear, we're creating tools and abstraction layers that let users choose what parts of the stack they want to get deep on and what parts they want to just work. In terms of what we're actually launching this year, this is the stuff that we talked about a little bit in the press release that I think came out yesterday, as well as we'll have some blog posts later this week, I believe, about this in more detail. You'll go to the next slide. Here's what we're focusing on this year to start kind of moving this story forward. It's the first of a lot of exciting stuff to come. So first, we've introduced what we're calling hosted workflows, quantum functions, and hybrid solvers, a collection of new interaction models that work together to enable these hybrid solutions and make them effective and simple, whether that's in the cloud, on-prem, or some combination, by packaging and simplifying the classical logic and infrastructure that allows those workloads to run. Second, we're introducing a scheduling capability called sessions, making sure that time to solution is maximized and resource utilization is also maximized is critical in the long term and in the short term. And so sessions really combines the best of on-demand scheduling and reservation-based scheduling to maximize both of those things. And third, we're rolling what we're calling an accelerated on-QPU runtime as part of the IonQ Quantum OS, and I'll talk about that more in a minute. And all of these, to be clear, are built flexibly and can work as enablers for partner capabilities like the NVIDIA CUDA-Q kernels that we took advantage of at the demo that Margaret mentioned at SC. Amazon Brackets hybrid jobs have been actually demoed just this week at reInvent as part of some capabilities that they're working on with Q Control, or Azure Quantum Sessions functionality, or in addition to that, directly through the IonQ Quantum Cloud or via our new IonQ SDK. And to be clear, again, this is really just the beginning. We have a series of additional enhancements planned to the things we just rolled out, as well as additional new features throughout the Forte Enterprise and Tempo timelines to get us to this goal of large commercial advantage applications running in production. I could talk about the kind of individual things that get us there, the bullets on this slide, but I'd rather talk about what this all builds to, which is a world where future developers don't care about physical qubits or physical machines and simply pass application inputs to production applications and get a quantum accelerated result. The value of these capabilities now is that it makes development easier, but in the long term, the value is that anyone who needs this power can leverage it regardless of quantum experience. And there's quite a bit of work to go here, but it all starts with this foundation we're laying right now today, allowing application developers to describe and schedule workloads in a way that creates these packaged portable descriptions of the computational goal, not just the quantum circuit. I mentioned I wanted to dig in a little bit on the IonQ Quantum OS, which is what we're going to do next. So, like I mentioned, one of the places we've been investing heavily in the past year or so is in this major revamp of the IonQ Quantum OS ahead of IonQ Forte Enterprise IonQ Forte moving into on-demand access and our first Forte Enterprise systems coming online very soon. Because Forte Enterprise has sort of always been our first system that was really supposed to live up to this enterprise-grade pillar. And for that to be true in every respect, it needed a control fabric worthy of that capability. If we'll go to the next slide, even calling it an OS, while a useful metaphor, kind of sells this thing short. It's really a platform that enables the continued rapid evolution of our R&D roadmap, our multi-QPU future. It includes a robust error mitigation suite, a variety of hybrid development, and it supports a variety of hybrid development integration models, and so much more. In addition to, if that wasn't enough, keeping our production systems running with high performance and availability. There are a ton of other amazing enhancements the team has made in getting the OS sort of ready for Forte Enterprise, ready for this enterprise-grade future that are described in more detail in the blog that's coming out later this week. So right now, I'm just going to focus on the kind of end-to-end application-oriented improvements we've been able to accomplish. These include some major speedups in what we call classical overhead, the time around when the ions are actually doing computation. And when combined with some additional clever scheduling and workload management techniques, these have translated to a speed up of something like kind of 2x, half the time in most cases, and in some extreme cases, up to 46 times. This is taking something that took a little over an hour down to a few minutes, all while keeping algorithmic quality steady, or in some cases even improving it by these advanced error mitigation techniques. And if you'll go to the next slide, these enhancements are already running on IonQ Forte and will be included at launch in all Forte Enterprise systems. They help take what is already an incredibly high-performance system and make it ideal for the kinds of hybrid workloads and deployment models we expect it to enable, whether that's via our cloud and hybrid services suite or integrated into a customer data center architecture. And like I said before, this really is just the beginning of the story. We're building a platform for the future here. And as excited as I am about what we've accomplished, I'm even more excited about the work ahead. And I think with that, I'm going to hand it off to my colleague, Masako, to talk about what our amazing applications team and partners have already been able to do with some of these capabilities on IonQ Forte. Thanks.
Thanks, Coleman. My name is Masako Yamada, and I'm